Hi, I'm Mr. Franklin, and today we're going to explore the conceptual use of Newton's equation for gravity. So the basic equation is the force of gravity equals g, which is the constant we've talked about, times the mass of the first object times the mass of the second object divided by the distance between them squared. So if I look at the picture, I have mass 1 and I have the second mass, and then I have a distance between them. If I actually know those numbers, I can plug them in and get a value that equals the force of gravity. Now, in the previous video, we showed that these are some pretty large or small numbers, and the actual calculations in our level of class is beyond the scope of our class, so we're going to kind of do this simply and think about it conceptually. So what I've done is in front of each variable, except for the constant, because the constant never changes, in front of each variable I've put a space to put a coefficient, and that's how much we're going to multiply times this value. So for example, if I take the force of gravity and I double the mass of the first mass, so I've doubled it, it's double in mass, and the mass of the second object stays the same, so 1 times m2, so the mass is staying the same, and the distance is staying the same, so I'm going to put a 1 in there. I can just do the math with the coefficients, and I can tell you how much this value is going to be. So 2 times 1 is 2, so I got 2 times 1 is 2, divided by 1 squared, so I got 2 divided by 1 squared, which equals 2. So that should go in front of the force of gravity. Because if I do it over on this side of the equation, I have to do it on that side of the equation. So 2 times the force of gravity. So if I double the mass, I'm going to actually double the force of gravity acting on the object. So I doubled this one, that one stayed the same, and the distance stayed the same. Okay? Let's take a look at another one. This time, we are going to triple the mass of the first one and double the mass of the second one, but keep the distance the same. So what's the overall force going to be? 3 times 2 is 6, divided by 1 squared, which is 1, so the answer is going to be 6. So the force is going to increase 6 times. So let's draw our picture. So this is actually going to be 3 times the size, which is kind of hard to judge without using graph paper. But mass 1 is now 3 times its original size, and mass 2 is now double its original size. Okay, but the distance stayed the same. So the force is going to increase by a factor of 6. Okay, now we're going to try one that's a little different. We're going to look at the radius. What happens if I double, keep the masses the same, so we're going to keep the masses the same, but I'm going to double the distance between them. So 1 times 1 is 1, divided by, be careful, this is inside the parentheses, so this is going to be 2 squared, so it's 1 divided by 4. So the further apart the objects get, the overall force is going to decrease by a factor of 1/4. And we could also say 0.25 times the force of gravity. Either one would be appropriate. What happens if I cut the distance between them? So we doubled the distance up here, and now we're going to halve the distance. So now the distance is half. Okay? So 1 times 1 is 1, divided by a half squared. A half squared equals, okay, 1 divided by, a half squared is the same as a 1/4. But notice I'm dividing by a fraction. When we divide by a fraction, we have to multiply times the reciprocal. So that is equal to 4. So the force is actually going to multiply times 4. So as the objects get closer together, the force is going to increase by a factor of 4. So just to recap, okay, this is our basic equation. When I double the mass of an object, we're multiplying the coefficient times that amount, so the force is going to double. We could actually plug this into our actual numbers from our previous video, and you would see that if you doubled the mass of the Earth, then the force would double to 19.6 instead of 9.8. If you tripled one and doubled the other, the force would increase by a factor of 6. So you can take all those numbers from our previous video and multiply them times these amounts, and you should get this as the factor by which this increased or decreased. So if the masses get bigger, it should make sense. If the mass gets bigger, it's on top of the fraction, the force has to get bigger. If the mass gets smaller, then the force is actually going to decrease. Okay. If the distance increases, they're getting farther apart, so we're dividing by a square number. So when we divide by a square number, the overall number is going to get smaller. However, when we bring them closer together, the number is going to get bigger. So while mass is important, notice what is one of the most important factors in this equation. It is the distance between them. Why? Because it is a square number. Alrighty, I have some practice problems posted on Google Classroom. Try those, and let's see how you do.